Hello, here we go with section 3.4, part 3, where we're going to do trickier stuff. Completing the square in situations where it's, well, first of all, where we have like 2x squared instead of just x squared. It makes it trickier. So, first thing we're going to do is the same thing as before, just get the constant on the other side without the x, so that both of the x terms are alone on one side. And then, at this point, here's a common mistake. And I'll let you know this is a mistake, and we'll see why it's a mistake. I just wanted to go over it, just so you know to watch out for it. And the common mistake is this. Looking at this, you could say, oh, that negative 6 is 2p. So you can divide that by 2 to get p. And then square that to get p squared, and that gives you 9 is your p squared. So if you add 9 to both sides, you'll get 2x squared minus 6x plus 9 equals 14. And then you say, okay, I've got the 2p is negative 6 and the p squared is 9. So this should factor into 2x minus 3 squared equals 14. And this is the mistake. And you can tell it's a mistake because if you actually FOIL this out, if you do 2x minus 3 times 2x minus 3, what you're going to get is 2x times 2x is 4x squared, minus 3 times 2x is minus 6x, and then minus the other 6x is that, and then negative 3 times negative 3 is plus 9, and the negative 6x's you can combine to make negative 12x, I guess. And this is not the same thing at all. This thing here is not the same thing at all as what you started with. So this was a mistake when we factored this. So the problem is that the equation that we're using, this general rule for squaring a binomial, you're only going to have 2px here and p squared if this was just x by itself, just 1 times x plus p. And it doesn't work at all. If you had like 2x plus p quantity squared, you'd get something totally different, not necessarily 2px and p squared here. To avoid this, here's what we do. To make this become just x squared, because our whole rule for completing the square only works if you just have x squared. So to deal with that, you can divide both sides by 2. So you just have x squared. So when you divide that by 2, you'll get just 2x squared over 2 is just x squared. And then we need to divide the negative 6x by 2 as well. That will give you negative 3x equals 5 over 2. And now with this, we can now complete the square with this one. So I'm going to say the 2 times p is equal to your negative 3 there. If you divide that by 2, you'll get p equals negative 3 over 2. And then when you square that, p squared is going to be negative 3 over 2 squared. And that's the same thing as squaring the top and squaring the bottom. So that's going to be negative 3 squared is 9 over 2 squared is 4. So that's your p squared is 9 over 4. That's what we're going to add to both sides. And oh, this is a little tricky to add these on this side. We need to make them have the same denominator. So I'm going to write the 5 over 2 as 10 over 4, just multiplying both sides by 2, and then plus that 9 over 4 there, turning these both into fourths so that you can combine them. That's going to give you 19. Oh, gosh. This cold sucks. 19 fourths. Alright. Now, we should be able to factor the left side into x minus 3 over 2 quantity squared equals 19 over 4. And you could check this by foiling this out. If you do x minus 3 over 2 times x minus 3 over 2, you should get this original trinomial that you had. Now we can take the square root of both sides and get this as x minus 3 over 2 equals the positive or negative square root 19 over 4. And then we can add this to both sides, this plus 3 halves. And that'll give you x equals, well, first of all, the square root, you can take the square root of the 19 and the square root of the 4 separately. The square root of 4 in the denominator is 2. So we can write this as 3 over 2 plus or minus the square root of 19, and then that divided by 2. And then because these are both over 2, you can combine them into one fraction. And that is your solution. Alright, tricky stuff. So here's one more of the same kind of thing where you have something times x squared instead of just x squared by itself. I recommend you try this one on your own. It is very tricky and you might make a mistake, but that's okay. You gotta make mistakes to learn how to get better. I'll show you how to do it after you've paused it right here and then tried it yourself. Okay, so now that you've tried it yourself, here is my my solution. I'm going to add 4 to both sides to get 3x squared minus x equals 4. Then I want to divide both sides by 4. By 3, what am I talking about? Because I want to get just x squared. And that will give you x squared minus 1/3 x equals 4/3. And complete the square now, we need to figure out what the p is and what the p squared is, so that negative 1/3 there is your 2p. If you divide that by 2, this gets a little bit ugly. So instead of dividing it by 2, I'm going to think of this as multiplying by 1/2, which is the same thing as dividing by 2. Because that way you know that the 1/2 times 2 cancels out. It gives you just 1 times p. And on the other side of this equation, you can multiply these fractions. The negative 1/3 times 1/2 will give you negative 1/6. So that's your p is negative 1/6. Now we can square that. So that's the same thing as just squaring the top and the bottom of it. And that negative 1 times negative 1 will give you 1. The 6 squared will give you 36. So that should be your p squared we're going to add to both sides. And this is really tricky when you have all these fractions, of course. So we're going to have x squared minus 1/3 x plus 1 over 36. And on the other side, how do we add these together? Well, let's try to make them have the same denominator. So I'll try to write the 4 over 3 as something over 36. Well, I can multiply 3 by 12 to get 36. So I can also multiply 4 by 12, which is 48. So 48 over 36 is the same as 4/3. You've got that plus 1/36. And then you can just combine those to say that's going to become 49 over 36. Then on the left side here, this should be factorable as x plus p quantity squared, and the p is -1 over 6. That should equal your 49 over 36 here. Then you can take the square root of both sides to get x minus 1/6 equals the positive square root of 49 over 36. And for that, you can take the square root of the top and bottom separately. The square root of 49 is 7. So you can write this as plus or minus 7 over the square root of 36 is 6. So then you can just add 1/6 to both sides of this. And you'll get x equals plus or minus 7 over 6 plus 1 over 6. And if you do the positive 7 over 6 plus 1 over 6, that gives you 8/6, which comes out to 4/3 if you reduce it. And if you do -7 plus 1, that will give you -6 over 6, which is -1. Whew. Okay, there's so many places to make mistakes here, dealing with all the fractions especially. But it's a challenge. You can get there if you just practice. Because these are so complicated sometimes, it does take a lot of practice to get proficient at it. And in order to get there, I recommend working in a place where you can constantly be checking your steps with somebody else. If you're working with a friend on these homework problems, and you can just check each step with them as you go, and that way you can identify mistakes quickly. Because it's a problem when you go all the way through the steps and you get an answer at the end that you realize is wrong, and then you realize that, oh, you just made a mistake at the beginning that you could have maybe caught at the beginning, and then you have to go back and redo a whole bunch of stuff again, and that's no fun. So yeah, make sure you're working in a place where you can hopefully catch mistakes early, like in class or in the CAS or with a friend, and just don't give up and keep practicing. All right, see you in class.